Okay, so hello everyone, welcome back. We're gonna take a look at section 6.3 today. So 6.3, matrices and system of equation. So for this section, we're gonna take a look at another method that we might use it to deal with system of equation. So after we talk about solving the system of equation by using look like graphic graphing methods, elimination methods, and substitution methods, right? So now we're gonna talk about another way that we might use it to get the solution of a system of equation. So matrices and system of equation. So in this section, we consider additional techniques for solving system of equation. You have probably observed it that when we solve a system of equation, we perform computation with the coefficient, right? So we actually based on the coefficient to determine if we need to multiply some equation by some numbers and add with another equation to eliminate some of the variable, right? So we're gonna base on that elimination methods, yeah. So you might observe in that when we solve a system of equation, we perform computation with the coefficient and the constant and continuously rewrite the variable. So we're gonna keep repeating the variables over and over. So it might take a lot of time. So that's why we might use in this method to look like make your work a little bit less. You don't have to carry over the variables over and over. We can streamline this solution process by omitting the variable until the solutions is found. So for example, let's take a look at the really maybe easy system of equation. We have 2x minus 3 is equal 7 and x plus 4y is equal -2. So in the previous section 6.2, right? So we talk about the elimination methods and the substitution methods, right? So you might use in that idea to deal with this system of equation, or we might use in matrix to deal with this system of equation. So if you're gonna rewrite this system of equation without the variable, so this system of equation can be written more simply as so the coefficient of x is 2, coefficient of y is -3, and the constant 7. The coefficient of x is equal 1, the coefficient of y is equal 4, and the constant equal -2. So we might combine them, we might simplify it as something look like this. And then the vertical lines over here is equality equal sign. So the vertical lines is replaced by the equal sign. So this is an example of a matrix. Okay, so this is an example of a matrix. So what's the names of this matrix and how we define a matrix, right? A rectangular array of number like the one above is called a matrix, or plural is gonna be matrices. Okay, so matrices. So this is a rectangular array with number. Okay, so we have -2, -3, 7, 1, 4, -2. So we have two arrays of number, and this make up a matrix. The matrix above is called the augmented matrix. So this is augmented matrix for the given system of equation. So from this system of equation, when you rewrite that using a matrix without carry over the variables, we only use the coefficient and the constant. This is an augmented matrix. Okay. But we also have another matrix over here. Okay. So the matrix above is called an augmented matrix for the given system of equation because it contains not only the coefficient, but it also contains the constant term. So it contains the coefficient for the variable x and y. It also contains the constant. So we call this is an augmented matrix. The matrix only contains the coefficient. It called the coefficient matrix. Yeah. So the matrix 2, -3, 1, 4. We call it the coefficient matrix of the system because it only shows the coefficient of the variables x and y in the original system of equation. Okay. So we have augmented matrix, and now we know the definition of a matrix, right? So matrix and augmented matrix and coefficient matrix. So we're gonna talk more about the matrix over here. Let's keep going, right? The row of a matrix are horizontals. Okay, so the row of a matrix is going to be horizontal. So for example, we have this matrix, hey, 2 rows, and the columns are vertical, and columns are vertical. So for this matrix, we have 3 columns, and then for this matrix, we have 2 columns. The augmented matrix above has 2 rows and 3 columns, and the coefficient matrix has 2 rows and 2 columns. A matrix with m row and n column is said to be of an order m by n. Okay, so m by n. So for a matrix, we always show the number of rows first, and then after that, the numbers of columns. So 3 rows, 5 columns, 2 rows, 3 columns. Yeah, so it's going to be 2 by 3. When you see 2 by 3, it means that a matrix have 2 rows and 3 columns. When you see 4 by 5, it means that's a matrix with 4 rows and 5 columns. Okay, the orders of the augmented matrix above is 2 by 3. So if you're gonna take a look of this augmented matrix over here, it's a 2 rows and 3 columns, right? So gonna be 2 by 3. For the coefficient matrix, it's a 2 rows and 2 columns. Okay, so 2 rows and 2 columns. The coefficient matrix has 2 rows and 2 columns, so gonna be 2 by 2. So when you have a matrix and then the numbers of rows equal the numbers of columns, we're going to call that matrix is a square matrix. When m, which is the numbers of rows, equal n, which is the numbers of columns, matrix is said to be a square matrix. The coefficient matrix above is a square matrix. Okay, so the coefficient matrix has 2 rows and 2 columns, so that's why this is a square matrix. The number 2 and 4, okay, the number 2s and 4s are in the main diagonal. The number 2 and the number 4 obvious are on the main diagonal. So 2 and 4, 2, 2. This number 2 and the number 4s are on the main diagonal. The numbers in a matrix are called the entries or the elements of a matrix. Okay, so each numbers in those matrix are called an entries or it's going to be an elements of a matrix. Okay. So that's just a few definitions, a few theories stuff related with matrix, right? Okay, so we talk about augmented matrix, we talk about coefficient matrix, we talk about the dimension of matrix also, right? So m by n is the numbers of row times the numbers of column. We also talk about square matrix. When the numbers of rows equal the numbers of column, we also talk about the main diagonals, right? So diagonals of a matrix. So 2s and 4s are on the main diagonals of the matrix. So each numbers on this matrix over here are called an entries or it's going to be elements of the matrix. Okay. So this look like gonna be introduction with matrix, right? And some of the terms that we use it relate with matrix. Now let's move on to the next page. Okay, so we're gonna take a look at the Gaussian elimination methods, right? So actually we're using Gaussian elimination methods in the previous chapter, right? Previous sections. Okay, so it's gonna be 6.1 and 6.2. So 6.2, we talk about Gaussian elimination methods, right? So now in 6.3, we're also using the ideas of Gaussian elimination, but we apply with a matrix. Gaussian elimination with matrices. So in section 6.2, we describe a series of operations that can be used to transform a system of equation to equivalent system. Okay. Each of these operations corresponding to one that can be used to produce rows equivalent matrix. Yeah. So one of the steps that we did in section 6.2, Gaussian elimination methods, is going to help us to produce some equivalent system, right? And those steps are also help us to produce rows equivalent matrix. Okay, rows equivalent matrix. Okay, so it's going to be equivalent matrix. So what's the rows equivalent operation that we might do with a matrix? Row equivalence operation with matrix. We might interchange any 2 rows. So interchange, it means that you can swap them around, right? So you can you interchange row 1 and row 2. You might interchange row 2s and row 3s, or you might interchange row 1 and row 2, right? So interchange it. Multiply each row Yeah, so multiply each entries in a row by the same non-zero constant. So it means that you multiply the entire equation by a non-zero number, right? So that's what we did in the previous section, 6.1 and 6.2. Yeah, multiply each entries in a row by the same non-zero constant. And then the third way, the third row equivalent, rows equivalent operation, we did that earlier also, but now we apply with the matrix. You add a non-zero multiples of one row to another row. So we did earlier, right? Look like you can take, look like that you multiply the second equation by a -2 and you add the answer with the first equation. That's what is step number 3. So we are the third row operation, row equivalent operation, okay? Add a non-zero multiples of one row. So you multiply the row by some non-zero number and you add with another row to produce some equivalent matrix C. Okay, so we're gonna use a matrix that can help us to approach the solution of a system of equation using augmented matrix, right? We can use this operation on the augmented matrix of a system of equation to solve the system, okay? So you're gonna use it 1, 2, so 3 over here and a combination of this that can help you to approach the solution of a system of equation. But keep in mind, we're gonna use a matrix, okay? So our goal is to find the rows equivalent matrix of the form. So what's the final step? How can we know that we approach the final answer? What's gonna be the final matrix we want to have? So for the final matrix, that it means it indicates that we have the solution. It means that on of the element or the entries on the main diagonal is gonna be 1. Okay, so you have to double check that on of the element or the entries on the main diagonal should be 1. And then on of the element or the entry below that gonna be 0. So if you have some matrices look like that, then that's gonna be the final step, and we're gonna use a back substitution to get the answer. Okay. So your job is we have to make sure that on of the element on the main diagonals is gonna be 1. And then on of the element below the diagonals is gonna be 0. Okay. So it depends on how big is the matrix that we have, right? So if you only have a look like two equation with 2 variables, then it's gonna be look like this. Make sure that you have 1 on the main diagonal, and then the element below that main diagonal is gonna be 0. If you're gonna get 3 equations with 3 variables, then the final step that you want to approach is gonna look like this. On of the number 1, on of the element on the main diagonal is gonna be 1, and then on of the elements below that's gonna be 0. So you might use one of the operation over here. Interchange 2 rows, multiply each row, multiply each entries of a row by a non-zero constant, and then add a non-zero multiples of one row to another row. Okay, so we're gonna use in that. So actually this based on the section 6.2 Gaussian elimination, right? So Gaussian elimination, that's help us, yeah. So now the only thing different is we're gonna use an augmented matrix. So you're not gonna carry over, you don't need to carry the variable x, y, z over and over. It might look lighter, but you have to make sure that you know the step by step. Yes, okay. So watch out for the calculation, because if you make any wrong calculation along the way, that's really affects the answer. Okay. Okay, so we're only gonna deal with the look like two equation with 2 variables, or 3 equation with 3 variables. Okay, let's do some practice over here. Keep in mind over here, everyone, rows equivalence operation. Interchange any 2 rows, multiply each entries in the row by the same non-zero constant, add a non-zero multiples of one row to another row. Okay, so now we're gonna, you might need to use a calculator to make sure that you double check your work to make sure that we have the answer right. Okay, so now let's try some practice question. We're gonna try with the 2 equation, 2 variables, right? We're gonna try with the small matrix first, okay? So solve the following system of equation using Gaussian elimination methods, or using Gaussian elimination matrix, okay? So we are given this system of equation. 2x plus y is equal 1, and then 3x plus 2y is equal -2. Okay. So you might using the idea from section 6.2, right? So you might using that, or now we're gonna use a matrix or matrices to help us to approach the final answer. So the very first step over here is if you're gonna use a matrix, then the first step you have to rewrite this as a augmented matrix. Okay. Rewrite the given system of equation in augmented matrix. Okay. Okay, so we're gonna use in a matrix over here, everyone. And this is gonna be my matrix right here. Okay, so you can see that this matrix is gonna have 2 rows and 3 columns over here, right? So we have 2 equations. So it's gonna be 2 rows and then we have 3 columns. 2 rows, 3 columns. So we just only print down the coefficient. Okay, so the first coefficient is 2, the second coefficient is 1, and then this is the constant, which is 1. And for the second equation, the coefficient is 3, and then it's gonna be 2, and it's gonna be -2. Okay. And then if you want, you can draw the vertical line to show the equal, right? So you know, oh, this is the coefficient of the variables, and this is the constant. Okay. So that's gonna be the purpose of this vertical line. So it's gonna separate, or we're gonna treat that as an equal. On equal side. Yeah, so on of the coefficient, on of the number, on of the entries or the element before the vertical line is gonna be the coefficient of the variable. So x, y, x, y. So 2x plus 1y is equal 1. And then 3x plus 2y is equal -2. So from the augmented matrix, you might need to get back to the system of equation. And from the system of equation, you might rewrite in terms of augmented matrix. Okay, so now let's keep going. So that's what we're gonna do next. Okay, so based on the summary that we have earlier, so now let's take a look at this coefficient. So on of the element on the main diagonal should be 1, and then on of the number below that's gonna be 0. Okay, so I'm gonna start with the first column first. Okay, so I'm gonna start with this element. I want to make that element equal 1. So what we're gonna do? So you might use in one of the row operation that we have earlier. You might interchange any 2 rows. You might multiply each entries in a row by the same non-zero constant. You might add a non-zero multiples of one row to another row. So one or the other, let's say which one is gonna help you to make this first elements right here equal 1. But whatever you do with this first elements over here, you have to do with the entire row. Okay, not just that's one element. You have to do with on of the entire rows over here. Multiply each entries in a row by a number, not just a single element. Even though that you want to make this single element equal 1, but the operation that we're using to affect this element, it can affect on of the other element in the same row. So I want to make this coefficient equal 1. So what we're gonna do? I'm gonna say that I'm gonna divide, right, or multiply by 1/2. Okay, so divide the first row by 2 to replace the first row. Okay, and I'm gonna recommend that you really be careful with the operation that we did over here. You might use a calculator to get the answer more accurate. Okay, so the first row is obvious. I will divide on up the term over here by 2. So 2 divided by 2 is gonna give you 1. 1 divided by 2 is gonna give you 1/2 or 0.5. 1 divided by 2 is gonna give you 0.5. You might keep it as a fraction or a decimal, make sure that it's gonna be equivalent. Yeah. For the second rows, I'm not gonna do anything, so we'll copy that. 3, 2, and -2. Make sure that everything looks good. Okay, so we have this is the first element on the main diagonal is equal 1. So that's good. Now, anything below that main diagonal is going to be 0. Okay, so the next step, I'm going to make this equal 0. I want to make this 3 is equal 0. Okay, so how we're going to make that element 3 is equal 0? Okay, so the element on the main diagonal is going to be 1. So we have this is the first one already. But so anything below that is going to be 0. So what we need to do to make it equal, this element equal 0. Okay. So we're going to use in the row operation that we have earlier. You might multiply one row by some numbers and add with another row, right? So in this case, if I want to make this element equal 0, I'm going to multiply the first equation by -3 and I will add with the second equation. Okay. Multiply the first row by -3 and add with the second row to replace the second row. Okay. So I should indicate which row will be replaced so you know what happened, right? So for the first rows, I'm not going to modify anything. I will keep it the same. So 1, 0.5, and 0.5. Now let's do the calculation. So we're going to take -3. You might use in a calculator to make sure that you got the answer more accurate, right? Yeah. So we're going to multiply the first row by -3 and then add with the second row. So the first row, we're going to take -3 times it by, times it by 1. We times the first row by -3, so -3 times it by 1, plus the second row will be 3. That's going to give you a 0, so this element will be 0. Now we're going to repeat the same process for all of the other elements. Okay, so we're going to take -3 times it by 0.5 and plus 2. Okay, -3 times it by 0.5 and plus 2. It's going to give you 0.5. And same thing over here for the third one. I'm going to take -3 times it by 0.5 plus a -2. -3 times it by 0.5 and plus a -2. Okay. It's going to be -3.5. Okay. So that looks good so far, right? So we have zeros on the main diagonal and then 0 below that. Now I'm going to move it on to the second elements on the main diagonal. So this is the first elements on the main diagonals. This is the second element on the main diagonal. Okay. So if that element belongs to the main diagonal, that element should be 1. So I have 1/2. So what I'm going to do to make this equal 1. Okay. So you might use in one of the row operation earlier, you might multiply, you might interchange the row, you might multiply each entries of a row by a non-zero number. You might add a multiples of one row to another row, right? Okay. So I think in this is 0.5, I'm going to multiply that by 2 to make it a whole number with the 1, right? Multiply the second row by 2. So I will multiply the second row by 2 and I will replace to the second row. Okay, so all of the elements in the second row will be multiplied by 2. So the first rows, I'm going to keep that. Now for the second row, so I'm going to take 2 times 0 is 0. 2 times 0.5 is going to give you 1. And then 2 times it by this. So 2 times -3.5 is going to give you -7. Okay, so let's double check if that's the final step. Do we need to know anything further? So double check. So on of the element on the main diagonals already equal 1, and then on of the element below that is already equal 0. So that looks good. So now we're going to use a back substitution. So let's observe in the second row. So from the second row, what we get? From the second row, we have, okay, so from the second row, we're going to put back the variable now, okay. So the first element for the variable x. So we have 0x plus 1y is equal -7. So 0x is going to be 0. So 1y, which is y. So we actually have the solution, right? Y is equal -7. Okay. So now we have the first solution. So what we're going to do next? So now we're going to substitute y is equal -7 into the first row because the first row still have x and y. So from the first row, we have what? We have 1x plus 0.5y equal 0.5. Okay. Now we're going to substitute y by -7. Okay, we're going to substitute y by -7. So, oh, this is x. Yeah. Don't make any typos along the ways, everyone. Okay, so we have 1x, which is x, plus 0.5 times it by -7 equal 0.5. Okay, so x plus 0.5 times -7 is going to give you -3.5 equal 0.5. Okay, now we're going to add 3.5, right? So solving for x, we have x equal 4. Okay, so we're good, right? So actually, it's kind of similar with section 6.2, right? Gaussian elimination methods that we have from 6.2, we might apply it for this section 6.3. The only thing differently, we apply it in terms of a matrix. Okay, so let me put the solution together. Okay, so the solution that we have is going to be in terms of an ordered pairs. X go first, so x equal 4, y is equal -7. Okay, so this is going to be the solution. Now, if you want to double check, if you want to make sure that we have the solution correctly, we might check it, right? So how we're going to check it? We're going to check the solution by substitute to the original equation. Okay, so I will copy that first equation. And now I will substitute x equal 4, so 2 times it by 4 plus y, which is -7, that's going to give you 1. Okay, so let's see. So 2 times it by 4 is 8, a plus a -7, so 8 minus 7 is 1 is equal 1, so that's good. So the first equation is true, right? Now we're going to check for the second equation. Let's give it a try. This is the second equation. Let's double check if it's true. Okay, so now once again, I will substitute x by 4, y by -7. So 3 times it by 4 plus 2 times it by -7 equal -2. Okay, so 3 times it by 4 is 12. 2 times -7 is -14. That's going to give you a -2. So 12 take away 14 is -2 is equal -2. So that's good. It's true. So the solution that we got so far is true for both of the equations. So that's good. So final answer, we can say that the solution is x equal 4 and y is equal -7. Okay. So the way that we're using matrix to deal with the system of equation is kind of similar with the Gaussian elimination method that we talk about in section 6.2, right? The only thing that you have to do, practice how to recognize which row, combine which rows, and then how we approach in the final answer. So once again, make sure that on of the element on the main diagonals gonna be 1, and then on of the element below that's gonna be 0. Okay, let's try another one. Okay, let's move on to question B. Okay, so we are given this system of equation x minus 4y is equal 9 and 2x plus 5y is equal 5. So once again, we're gonna use a matrix to get the solution of this system of equation. So first step, we need to rewrite this system of equation in augmented matrix. Rewrite given system of equation in augmented matrix. Okay. Okay, so for this matrix, we have 2 rows and 3 columns, right? So we're gonna have a 2 rows and 3 column matrix. And we only just copy the coefficient and the constant. So it's gonna be 1, -4, 9, 2, 5, and 5. Okay. So this is the augmented matrix, and once again, you might draw a vertical line to indicate which numbers or which entries belong to the coefficient of the variables and which one is a constant. Okay, so on of the element before the vertical lines is going to be the coefficient of the variables x and y, and then the number after that vertical lines is going to be constant. So once again, from this given augmented matrix, you might rewrite in terms of a system of equation, and from a system of equation, you might come up with the augmented matrix. Okay, so let's use this matrix to approach in order to find out the solution. So once again, you're gonna double check. Okay, so the on of the element on the main diagonal gonna be 1. So we're gonna start from the first element on the main diagonal. Okay, so this guy. Okay. Oh, luckily that this element's already equal 1. So that's good, right? We don't need to do anything. It's already equal 1. So this element's already equal 1. Then anything below that's gonna be 0. So now I want to make this element gonna be 0. I want to make this entries or this element must be 0. So what we're gonna do? What you guys think? So we're gonna use in rows equivalent operation, right? So interchange any 2 rows, multiply each entries in a row by a non-zero number, add a non-zero multiples of one row to another row. Okay, so I want to make this elements equal 0. So look like I have to do something with the first row, so I can add with the second row to make this elements equal 0. Okay, so I will multiply the first row by -2 and add to the second row to replace the second row. Okay, so I have to indicate which rows I will replace. Okay, so based on that, you can know that which row will be affected and which row that I will keep it. Okay, so because I say that I multiply the first row by the -2 and add it to the second row to replace the second row. So I only change in the second row. The first rows, I will copy that. So 1, -4, 9. The second row, now we're going to do all the operation. Multiply the first row by -2. -2 times it by 1 is -2. -2 plus 2 is going to be 0. Or you might do with the calculator to be safe, right? Okay, so we're going to take -2 times it by 1 and plus a 2. So it's going to be 0. That's how we got this element 0. Now, same thing, we're going to take -2 times it by this element, the first row, which is -4, plus the second row, which is +3. It's going to give you, okay, so -2 times a -2 is 8a plus 5 is going to be, oh, sorry. Okay, so -2 times it by -4 plus a 5 is going to give you 13. Okay, so this is going to be 13 right here. Okay, now similar idea, let's do the last one. We have -2 times it by the first row, which is 9, plus the second row, which is 5. Let's see what's it going to be, -13. Okay, so we have the element on the diagonal. The first elements on the main diagonal is already 1, and then the number below that's going to be 0. So that's good. Now we're going to move on the second element on the main diagonal. This is 13 right here. But you don't want to get the 13 right there. You want to make that numbers equal 1. So what we're going to do? What you're going to do to make these elements equal 1? So look like this is 13. So I will multiply by, or I can say divided by 13. Divide the second row by 13 to replace the second row. So once again, I modify the second row. So the first row is cut and paste. We're gonna copy the first row, nothing changed it. 1, -4, 9. Now the second row, what we're gonna get? 0 divided by 13, so it's gonna be 0. 13. Oh, don't forget the negatives. I have a negative earlier, so put it there. Yeah, okay. So 13 divided by 13 is gonna give you 1. Negative 13 divided by 13 is gonna give you a -1. Okay, so that's what we have. Now double check, are we done? On of the element on the main diagonals, it's gonna be 1, and then anything below that's gonna be 0. Okay, so that looks good. Now we're ready to do back substitution. We substitute from the back, right? Okay, so we start from the last equation or the last row. So from the second row, we have what? From the second row, we have 0x plus 1y is equal -1. Or actually, we do have the solution y is equal -1, right? Okay, so that's good. We have the solution for the variable y. Now, after we know y is equal -1, we're going to substitute to the equation in the first row. Okay, so from the first row, we have what? So we have 1x minus 4y equal 9. Substitute x by negative, substitute y by -1. Okay. So we have x minus 4 times it by -1 equal 9. So x plus 4 equal 9. So now we're going to subtract 4 from both sides over here. So we have x equal 5. Okay. So we have the solution for y is equal -1. We have the solution for x equal 5. So we're going to put it together. So the solution we have is going to be, what is it? It's going to be an ordered pair, 5, -1. But, okay, so before we input the answer in my math lab, right, make sure that you're going to double check it. Yeah, so it's better that we can double check it first, make sure that we got the solution right. Okay. So I will copy the first equation and I will substitute the solution that we have and see if it's true. So this is the first equation. I will substitute x equal 5 minus 4 times it by -1, y is equal -1. That's going to give you 9. So -4 times -1 give you +4. 5 plus 4 is 9, so it's equal 9. So that's true. That's good. Similar idea, we're going to check for the second equation. Let's see if it's true. Okay, so I will substitute x by 5 plus 5 times y by -1. That's going to give you a 5. Let's see. So 2 times 5 is 10. 5 times -1 is -5. 10 take away 5 is 5, and 5 is equal 5. This is true also. Okay, so we can accept this final answer. The solution we have so far is x equal 5 and y is equal -1. Okay. Okay, so we actually just try to practice question with a system of 2 equations into variables, and we're using the Gaussian elimination matrix that help us to get the solution, right? Okay, so now we're gonna move it on to a bigger puzzle, right? So we're gonna take a look at 3 equations with 3 variables, okay? So hopefully make sure that you double check your work for every single step. Don't make any mistake along the way because that's going to cost you a lot of work to go back and double check. Okay, so now let's take a look at this system of equation, everyone. We are given 3 equations with 3 variables, right? Okay, so it's going to be similar with what we did in the previous 2 examples. We're going to rewrite them in augmented matrix first. Write the given system of equation in augmented matrix. So for this case, we're gonna get how big is this matrix? There should be 3 rows and 4 columns, right? We have 3 columns for x, y, and z, and we have another column for the constant. So that's why this matrix, we have 3 rows and 4 columns. Okay, so 3 rows and 4 columns. Okay, so we only copy the coefficient. So 1, -1, 2. And this element is going to be 0. Okay. And now we have 1, -2, 3, 11. And we have this is 2, -2, 1. And it's going to be -3. Okay. And once again, you might draw the vertical line to separate the coefficient and the constant. Okay. So this is going to be the vertical lines. I'll use it to indicate if we have on of the number before that, it's going to be the coefficient of the variables, and then on of the number after that's going to be the coefficient. Okay, so once again, now let's go. Okay, so the idea is you want to approach in, or you want to get some equivalent matrix with the one we have on up. The element on the main diagonal should be 1, and then on of the element below that's going to be 0. So we start from the first element on the main diagonal. This guy's over here. So this element's already equal 1, so that's good. Okay, we're good, right? So we're going to keep that one over here. And now we're going to make on of the element below that's going to be 0. Okay, so we're going to keep this element because it's on the main diagonals and it's already equal 1. So we keep that. But on of the number below that's going to be 0. So I will do step by step. Okay, so I will deal with this number 1. So over in the red color, I want to make that elements equal 0. So what we're going to do? So once again, we're going to use the 3 row operation. Yeah, row equivalent operation that we have earlier to make that elements equal 0. You might interchange 2 row, any 2 row. You might multiply each entries of a row in a row. Yeah, so each entries in a row by a non-zero number. You might add a non-zero multiples of 1 row to another row. Okay, so I want to make this elements equal 0. So what I'm going to do, I'm thinking that I'm going to multiply the first row by -1 and add it with the second row. Okay, so I will multiply the first row by -1 and add it to the second row to replace the second row. Okay. Okay, so let's see. I'm gonna get the matrix first. I need to add another one. Okay, so because I'm gonna replay the second row, so the first rows and the third rows, I will copy that. So I'm gonna copy the first row, 1, -1, 2, and 0. And the third rows, I will copy that also 2, -2, 1, negative. Oh, wrong place. -3. Okay, so the only thing that I'm going to modify is just the second row. So I modify the second row by multiply the first row by -1 and add it with the second row. Okay, so -1 times 1 is -1 plus a 0 plus a 1 is going to give you a 0. Okay, -1 times -1 is +1, right? So +1 plus a -2 is going to give you a -1. Okay. -1 times it by 2, say -2, -2 plus 3, -2 plus 3 is going to give you +1. That's good. Now -1 times 0 is 0, right? -1 times 0 is 0 plus 11, so it's going to be 11. Okay, so that's good. Now we have the first elements on the main diagonals equal 1, and this elements already equal 0. Now we're going to go down more. I'm going to make this elements equal 0. Okay, so what we need to do to make that elements equal 0? So in order to make this elements equal 0, I think that I'm going to multiply the first row by -2 and add with the third row to replace the third row. Okay, so I will multiply the first row by -2 and add it to the third row to replace the third row. Okay. Okay, so once again, for this step obvious, I only replace the third rows over here, right? So on the other rows, I will just copy that, right? So the first row that we have so far, 1, -1, 2, 0. I will copy the first row. And the second rows, I will copy that also 0, -1, 1, and 11. And now the third one is gonna get modified, it's got changed, right? I will multiply the first row by -2 and add it with the third row. So -2 times it by 1 is -2. -2 plus 2 is a 0. Yay, that's good, that's a 0. Now -2 times it by -2 times it by -1. It's gonna give you +2, right? +2 plus 2, +2 plus a -2. It's gonna give you 0. Okay, that's good also. And same thing over here, what we're gonna get -2, -2 times it by 2 is -4, -4 plus 1 is -3. -2 times it by a 0 is 0 plus a -3 is gonna be -3. Okay. Okay, let's double check what we need to do next. Okay, so we just double check the first element on the main diagonals equal 1, and then anything below that is gonna be 0. So that's good. Now we're gonna move it on to the second elements on the main diagonal. This guy's over here, this number's over here. I want to make that number equal +1, not a -1. So what we're gonna do? So this is a -1. So look like you can say you divide it by the -1 or multiply by the -1, right? To make this coefficient equal +1. Okay. So I will say I will multiply the second row by -1 to replace the second row. Okay, so let's keep going. Make sure that we don't make any typos, error. Okay, so the first row will be copied that 1, -1, 2, and 0. The second row, I will multiply by -1. -1 times 0 is 0. Any number times 0 will be 0. -1 times -1, -1 times -1 is +1. -1 times 1 is -1. -1 times 11 is -11. Okay, the third rows I will copy that 0, 0, -3, and -3. Okay, now let's double check what next. So the first, so the first element on the main diagonal is 1, and it on everything else below that is 0. That's good. The second element on the main diagonal is 1, and everything below that is a 0. Now that's good. Now we're gonna move on to the third element on the main diagonal, so which is -3. So the third element on the main diagonal, this is -3. But we don't want to get that -3. You have to make that equal a +1, right? Equal 1. So what you're gonna do to make these elements equal 1. So I'm gonna divide it by -3. Okay, so I will divide the third row by -3 to replace the third row. Okay, so I only modify the third row. So on of the other rows, I will copy and paste. Okay, make sure I copy it right. 1, -1, 2, 0. Okay, and this is 0. It's gonna be 1. This is -1, and this is negative 11. That's gonna be okay. So the third row I will divide it by negative 3, right? So 0 divided by negative 3 is gonna be 0. 0 divided by negative 3 is 0. Divided by negative 3 is gonna be 0. Negative 3 divided by negative 3 is gonna give you a 1. Negative 3 divided by negative 3 is gonna give you a 1. Oh, good. Now let's double check. So one of the element on the main diagonals equal 1, and one of the element below that main diagonals already equal 0. So that's good. Okay. Now we're gonna use in back substitution, right? So get ready. Let's find out the solution. So from the third row, we have what? So it's gonna be 0x plus 0y plus 1z equal 1. Or actually we have z is equal 1. Okay. So we have the solution for the variable z. Okay. Now what we do next? So after we got the solution for variable z, now we substitute to the second equation and we solve it for y, right? We solve for y solution. Okay. So from the second equation, from the second row, so 0x plus 1y minus 1z is equal negative 11. And then we know that z is equal 1. So we will substitute z by 1. Okay. So 0x is just 0, right? 1y is just y minus 1 times it by 1 equal negative 11. Okay. So we're going to get y minus 1 is equal y minus 1 equal negative 11. And then we add 1 to both sides. So we have y is equal negative 10. Okay. So we have the solution for the second variable, which is y. Now we're ready to find out the solution for x, right? So now we're going to use the first row. From the first row, we got what? From the first row, we have okay, so what's the equation we have from the first row? It's going to be 1x minus 1y plus 2z is equal to 0. So 1x minus 1y plus 2z is equal to 0. Let me change it back to the black one. Okay, so now I will substitute z by 1 and y by negative 10. We're going to substitute z by 1 and y by negative 10. Okay, so we have x minus y, so minus negative 10 plus 2 times it by 1 equal 0. Okay. Okay, so let's see what we're going to get. X minus a negative 10, that becomes plus 10. Plus 2 times 1 is 2 is equal 0. So now we have x plus 12 is equal 0. And now we're going to subtract 12, so we have x equal negative 12. Okay, so we have the third solution right here. We have the third solution, x equal negative 12. Now let's put all of them together. The solution that we have is going to be alphabetical order. X equal negative 12. Y is equal negative 10. What is z? Z is equal 1. Okay, so that's the solution. But how can we check the answer? You want to make sure that you don't make any typos, make any mistake along the way. So before we accept this solution, we're going to plug into the three original equation and check. Okay, so I'm going to copy the first equation and we'll check that first. Okay, so this is the first equation. I will substitute x by negative 12. So negative 12 minus y with a minus 10. And plus 2 times z, z with a 1. Let's see, that's going to give you a 0. So negative 12 minus a negative 10, that becomes plus 10. 2 times 1 is 2, so that's going to be 0. Let's see. Negative 12 plus 10 is negative 2. Negative 2 plus 2 is 0. So we have 0 is equal to 0. Check. The first equation is good. Now the second equation, let's see if it's true. So in order to be a solution, it must be true for one of the equation in the original system, right? So that's why we have to make sure. So x equal negative 12 minus 2 times y, which is negative 10, and plus 2 times, no, 3 times, plus 3 times z, which is 1. That's going to give you 11. We will find out. So negative 12. Negative 2 times it by 10 is going to give you positive 20 plus 3. That's equal 11. We'll check. Negative 12 plus 20 is going to give you positive 8. Positive 8 plus 3 is 11 equals 11. It's true. Oof, that's good. Now, one more equation to double check. If it's true for the third one, then we're good to go, right? So it means that this is going to be the solution. Yeah, so make sure that we're going to check for one of the equation in the original question. So x equal negative 12, so 2 times a negative 12 minus 2 times it by y is negative 10 plus z, which is 1, that's going to give you negative 3. Okay. So 2 times negative 12 is negative 24. Negative 2 times negative 10 is positive 20 plus 1, that's going to give you negative 3. We'll find out soon. Negative 24 plus 20 is going to give you negative 4. Negative 4 plus 1 is negative 3 is equal negative 3. That's good. So the solution that we have so far is true for the first equation, it's true for the second equation, it's also true for the third equation. So this is the final answer. We did it good. So the solution is going to be negative 12, negative 10, and positive 1. So x equal negative 12, y is equal negative 10, and z is equal positive 1. Okay, so let's keep going, everyone. We have one more question with the 3 equation, with a system of 3 equations, 3 variables, and we're going to use a matrix. So let's try one more practice question. Let's take a look at question D. Okay, so 3x plus 2y plus 2z is equal 3, and then x plus 2y minus 1z is equal 5, and then 2x minus 4y plus z is equal 0. We're gonna find the solution of this system of equation using matrix. Okay. So once again, we need to rewrite as augmented matrix first. So rewrite the given equation, the given system of equation in augmented matrix. Okay, so for this matrix, there is 3 rows and 4 columns, right? So 3 rows and 4 columns. Okay, so let me add another column. Okay, so it's gonna be 3, 2, 2, and it's gonna be 3. Move on to the next one. 1, 2, negative 1, and 5. And go down to the next one. 2, negative 4, 1, and 0. Okay. Okay, so once again, you might draw the vertical line to indicate the coefficient matrix and the constant number, right? So you might draw a vertical line right here to indicate that all of the number before that's vertical lines are the coefficient, and then the number after that's vertical lines is gonna be the constant. Okay, so once again, so we want to get all of the element on the main diagonals. It's gonna be 1, and then all of the element below that's gonna be 0. So this is the first element on the main diagonal, and it's equal 3. So we want to make this equal 1, right? So this is the thing that we haven't done earlier. So you might interchange it. You can say, oh, this second row over here has the coefficient equal 1. So I might interchange row 1 and row 2. Okay, so let's try it. You might interchange 2 rows, right? So interchange row 1 and row 2. Okay, so it means that we're gonna swap them. Make sure that you're gonna swap the entire row, right? So we're gonna interchange on up the element in row 1 and then on up the element to row 2. So row 2 will move up to row 1. Okay, so now we're gonna get 1, 2, -1, and 5. Okay, and then row 2 now it becomes 3, 2, 2, and 3. And row number 3, we're going to copy that to -4, 1, and 0. Okay. So you might interchange any 2 rows in the given augmented matrix. So the purpose is you want to get the first element. You want to get the first element right here. You want to get the first element on the main diagonals equal 1. Okay. Okay, so once again, you can draw the vertical lines over here to separate it. That should be okay, but no, that's fine. Okay. Now, so we have the first elements on the main diagonals equal 1. Now I want to make on of the element below that's going to be 0. So I want to make this first element right here. The first number right underneath that element gonna be 0. So what we're gonna do? Okay. So if you want to make this element, this entry is equal 0, I think that we're gonna use in row 1 and row 2 now, right? Row 1 and row 2. So I will multiply row 1 by -3, multiply the first row by -3, and add to the second row to replace row to replace the second row. Okay. Okay. So the first rows, so based on my sentinel, I'm gonna replace the second row only, right? To replace the second row. So the first rows I will copy that 1, 2, -1, and 5. So I will copy that. The third row I also copy that to -4, 1, and 0. Only the second row got modified. So what's going to be the element on the second row now? Okay, so I'm going to multiply the first row by -3. So -3 times it by 1 is -3 plus 3, so it's going to be 0. -3 times it by 2. -3 times it by 2 is -6. -3 times it by 2 is -6 plus 2, so it's going to be -4. Okay. -3 times it by -1 is +3. +3 plus 2 is going to be 5. Okay, so it's going to be 5. That's good. And now let's move on. So over here, -3 times it by 5 is -15. -3 times it by 5, -15. -15 plus 3 is going to be -12. Okay, -12. Okay, so that's what we got, right? -12. -3. Let me double check first. -3 cancel. -3, -6 gonna be 4. -3. 3 is gonna be 5. -3, -15, 12. Okay, so that's what we got. Okay, so that's good. Now we have the main diagonal. The first element on the main diagonal is equal 1, and these elements below that's going to be 0. Now we have one more place over here. I'm going to make that elements equal 0. So in order to make that elements equal 0, look like it's similar with the previous step. I'm going to multiply the first row by -2, right? Multiply the first row by -2 and add with the third row to replace the third row. Yeah, so multiply the first row by -2 and add it to to the third row to replace the third row. Okay, so I'm gonna only replay the third row. So on of the other rows, I will copy that, right? So on of the other row 1 and row 2, I will copy that real quick. 1, 2, -1, 5. And this is 0. And this is gonna be -4. And this is gonna be 5. And this is gonna be -12. That's good. Now the third row will be modified. I'm gonna multiply the first row by -2. -2 times 1 is -2 plus the third row which is +2. So gonna give you a 0. -2 times it by 2. -2 times it by 2 is -4, right? -2 times 2 is gonna be -4 plus a -4 is gonna be -8. -2 times it by 1 is going to give you a +2. +2 plus 1 is going to give you a 3. And same thing over here. Let's do it. -2 times it by 5 is -10. -10 plus a 0 is a -10. Okay. So for the first elements on the main diagonal, we have that's equal 1, and then on up the element below, that is already equal 0, so that's good. Now we're gonna move on to the second element on the main diagonal. Okay, so move on the second element on the main diagonal, which is -4. But you don't want to make that equal -4, right? Okay, so if you want to make that equal 1, then what we're gonna do? Okay. So for this case, I'm thinking that I'm gonna divide this entire second row by -4. Okay, so divide second row by -4. Okay. So I'm gonna divide the second row by -4, right? So the first row and the third rows, I will copy that. Nothing affected, right? The first one is 1, 2, -1 and 5. The third row is 0, -8, +3, and this is -10. Okay. So now the second row, we're gonna multiply or we divide on of the elements on the second row by -4. 0 divided by -4 still equal 0. -4 divided by -4 is gonna give you +1. Now 5 divided by -4, you might using your calculator, right? So 5 divided by -4, 5 divided by -4 is gonna give you -1.25. -1.25, and then -12 divided by -4 is going to give you a +3, right? -12 divided by -4 is going to give you +3. Okay. So that's what we have so far. Now let's say what next. Okay, so we have the second elements on the main diagonal already is equal 1. So that's good. Now we want to make this guys over here, the element right under that gonna be 0. Okay. So we want to make this -8 equal 0. So I'm thinking I'm gonna use the second and the third rows over here. I might multiply the second row by 8. The second row by 8 and add to the third row to replace the third row. Okay. Okay, so once again, I only modify or replace the third row. So the first rows and the second rows, I will copy that. Okay, so the first one, 1, 2, -1, 5. The second row is the same, 0, 1, -1.25, and this is gonna be 3. Okay. Now the third row, what's it gonna be? We multiply the second row by 8 and we add with the third row. So 8 times 0 is 0 plus a 0, so that's gonna be just a 0. 8 times 1 is 8 plus a negative 8. That's going to give you a 0. Now we might need to multiply this. Okay. Okay, so we multiply by 8, negative 1.25 times it by 8, and then plus 3, right? And plus the third row, so plus 3, negative 7. Okay. Yeah, so we're going to give you negative 7 right here. Okay. Now, similar idea, we can do this with the last one. So going to be 8 times it by 3 plus a negative 10. Okay. It's going to be 14. Okay, so that's good. Now we have the second elements on the main diagonals already equal 0s, and on the element below that's this element is equal 1, and then on the element below that's going to be 0, so that's good. Yeah, so the second element on the main diagonals already equal 1, and then on the element below that is 0, so that's good. Now we're going to move on to the third element on the main diagonal. So this is the third element right here is equal negative 7. But you don't want to get that equal negative 7. You want to make that elements equal positive 1, right? So we're going to divide it by negative 7. Divide the third row by negative 7 to replace the third row. Okay. So once again, we only modify the third row. So the first rows and the second row, the first row and the second rows, I will cut and paste. So 1, 2, negative 1, 5. This is 0. This is 1, negative 1.25. And this is 3. And this is divided by negative 7. The third row we got divided by negative 7. 0 divided by negative 7 is still 0. 0 divided by negative 7 is 0. Negative 7 divided by negative 7 is going to give you 1. 14 divided by negative 7 is going to give you a negative 2. Okay, this is what we have so far, everyone, right? Okay. Now, let's double check. So we have on of the element on the main diagonals already is equal 1, and then on of the element below that's already equal 0. So now we're ready to do back substitution, right? Okay, so from the third row, we have what? So from the third row, we have 0x plus 0y plus 1z is equal negative 2. Or actually, we have the solution for z is equal negative 2. Okay, so we have the solution for the first variable, which is z is equal negative 2. So now we're going to use in this solution, we substitute to the second rows and we got the solution for y. Okay, so from the second row, we have what? So going to be 0x plus 1y minus 1.25 z equal 3. Okay. Now 0x is just a 0, right? So 1y is just y minus 1.25 times it by negative 2. Okay. Equal 3. Okay. Now let's solve in this, everyone. So y negative 1.5 times it by negative 2. Negative 1.25 times it by negative 2. It's going to give you 2.5. So y plus 2.5 equal 3. And then we're going to subtract 2.5 from both sides. So we have y is equal 0.5. Okay. Now we have the second solution, y is equal, the solution for the second variable, y is equal 1/2 or y is equal 0.5. Now we're ready to find out the solution for the last variable, which is x over here, right? So from the first equation, what do we get? From the first row, okay, so from the first row, what do we get? So 1x plus 2y minus 1z is equal 5. Okay, so 1x plus 2y, right? Plus 2y, 1x plus 2y minus 1z is equal 5. 1x plus 2y minus 1z is equal 5. Make sure that I got everything right. 1x plus 2y minus 1z is equal 5. Okay. So now we will substitute everything. Okay, so x is something we need to find out, plus 2 times it by y. Sorry, this is 2y. And y is 0.5. Minus 1z. And what is z? Z is equal -2 minus a -2 equal 5. Okay, so x plus 2 times 0.5 is going to give you 1 minus a -2. That becomes plus 2 equal 5. Now x plus 3 equal 5. And now we're going to subtract 3 from both sides, right? So we have x equal 2. Okay. Okay, so we have the solution for the third variables, x right there. So now let's put all of them together. So the solution, so going to be alphabetical orders, everyone. So x equal 2, y is equal 0.5, or you can put it equal 1/2, right? And then z is equal -2. Okay, but if that's really the correct answer, how can we know? So once again, in order to know if this answer is good, we're going to check it real quick, right? Okay, so let's check this real quick. You can go back to the original system of equation and check for each of the original equation. I'm going to check for the first one. Okay, so we know x equals 2. So 3 times it by 2 plus 2 times it by 0.5 plus 2 times it by -2. That's going to give you a 3. We'll find out. So 3 times 2 is 6. 2 times 1/2 is going to give you 1. And then 2 times -2 is going to give you -4. That's going to give you a 3. So 6 plus 1 is 7. 7 take away 4 is 3 is equal 3. So it's true for the first equation. Okay. How about the second equation? Let's see if it's true. Okay, so we're going to substitute again. So x equal 2 plus 2 times y is 0.5. And then minus z, so minus a -2, so that's going to give you a 5. We will find out. So 2 plus 2 times 0.5 is equal 1, minus a -2 become a plus 2, that's going to be 5. 2 plus 1 is 3, plus another 2, so 5 is equal 5. Yay, is it true for the second equation? Almost there, right? How about the third one? If it's true for the third one, then everything's good. We'll copy the third equation and we're going to check it. Okay, let's see if it's true for the third equation. So this is the third equation. I will substitute x by 2 minus 4 times y, and y is equal 5. And then plus z, and z is -2. That's going to be 0. Okay, hopefully. So 2 times 2 is equal 4. -4 times 0.5 is going to be -2, and -2 that's equal 0. So 4 take away 2 is 2, take away another 2 is 0, so 0 is equal 0. That's true. Okay, so that's good, right? So this is going to be the final answer. We have the solution, x equal 2, y is equal 0.5, so 1/2, and then z is equal -2. Okay. So once again, this is the fourth examples, or this is the second example for a 3 by, it's going to be a 3 equation with 3 variables, and how we use a matrices to help us to get the solution. Okay, so this is another option. The good thing about this method is you don't have to look like carry the variables all over the way, right? So you don't have to repeat carrying the variable x, y, and z to form up your calculation. It might kind of tedious, but it might be, it's similar with the method that we talk about in 6.2, Gaussian elimination method, but you have to know one of the row operation, rows equivalent operation. So what are they? So actually on of the question that we did so far, the thing that we're using is just the 3 row operation that we have at the very beginning. So let's go back and review this real quick before we end the section, right? So rows equivalent operation. So we're gonna interchange any 2 rows, multiply each entries in a row by the same non-zero constant, add a non-zero multiples of one row to another row. So on up the question, on up the step-by-step that we did so far using matrices to plot the final answer for a system of equation, we're gonna apply maybe those 3 row equivalent operation. Okay, so we actually end the section 6.3. So this is the conclusion of section 6.3, solving system of equation using matrices, right? So the step-by-step is kind of lengthy also. You need to practice how to using the row operation, rows equivalent operation. That's really much. Okay, so this is the conclusion of 6.3. You might stop the recording and do the homework for 6.3, right? I will see you next time for 6.7.